In this video, we will learn how to find the values of the 6 trig functions if we're given the quadrant and one of the functions. Problem number 1. Let's draw ourselves a picture of this angle. We know that it's got to be in the 4th quadrant because they tell us 4th quadrant, so let's draw the angle into the 4th quadrant. Okay? Let's go ahead and make a triangle out of it, right, by doing this, so we have a right triangle. Okay? Now, look at this reference angle as we do the problem. Even though the true angle theta is here in standard position, we can use the reference angle as long as we're careful about the signs. So when I look at the sine of theta, right, meaning sine of theta, I'm thinking the definition of sine is opposite over hypotenuse. Opposite over hypotenuse. So from this reference angle, opposite is 2 and the hypotenuse is 5. So I said we needed to be careful about the signs. All right, now's the time. The radius is always going to be a positive number. But I have to be careful about the other coordinates. So because this is down 2, okay, all right, this would be a negative 2. And we don't have the x coordinate yet. But so we need to put this as a negative 2 because it's down 2. It's a y value. All right, we need to find the x coordinate, all right, the horizontal length. So let's call it x and let's do the Pythagorean Theorem. So if I have a squared plus b squared equals c squared, that's x squared plus negative 2 squared. Actually, we don't even have to deal with the signs at this point. Let's just treat this as a triangle. And we can just look at it and know, hey, if it's to the left, if it's negative, if it's to the right, it's positive. So x squared plus 2 squared is equal to 5 squared. That means x squared plus 4 if I subtract 4 from both sides, I get x squared equals 21. And if I take the square root of both sides, I'm going to get x equals radical 21. Okay, so I can put that in. So this is radical 21. So now I'm supposed to write the 6 trig functions based on this. So here I go. Let's start with the one I already know. Sine of theta. Okay, by the way, this radical 21, can I just leave it a positive or do I need to put a negative sign in front? I'm going to leave it positive because it's to the right and x values are positive to the right. So sine is opposite leg over hypotenuse. So that's going to be negative 2 over 5. Cosine is adjacent leg over hypotenuse. So that's going to be radical 21 over 5. Tangent is opposite over adjacent. So negative 2 over radical 21. All right, now we'll do the reciprocal trig functions. All right, the reciprocal of sine is cosecant. So cosecant will be the reciprocal of this, so that'll be 5 over negative 2. And the reciprocal of cosine is secant. So that's going to be 5 over radical 21. And the reciprocal of tangent is cotangent. So that'll be radical 21 over negative 2. Okay, so that's it. That's how you do number 1. Number 2 is very similar. Let's draw ourselves a picture. They told us it will be in the second quadrant. All right, so the second quadrant will be out here. Now, again, it's the sine function. So like we said before, we know that sine is opposite over hypotenuse. So when you look at this, we're going to be using this reference angle right here. Opposite, so that would put the 2 here, and the hypotenuse, 9, would go here. Now we have to be careful about the sine. You know, it's confusing because I have the sine function and then I have sine as in positive, negative. Right now I'm talking about whether things are positive or negative. The radius here is always positive. Will this value be positive? Yes, because it's up. Okay, so that'll definitely be a positive 2. So what we need to find is the x value right here. So let's do the Pythagorean theorem. So if we do x squared plus 2 squared is equal to 9 squared, a squared, b squared, c squared. That means x squared plus 4 is equal to 81. All right, subtracting 4 from both sides. That gives me x squared is equal to 77. All right, then you go ahead and take the square root of both sides. And now you have x is equal to the square root of 77. All right, and now we're ready to wait. Now we're ready to wait. Is this going to be positive, or do we need to put a negative sign on here? This is going to need a negative sign, all right, because it is going to the left side, and x values are negative on the left. So now I can do all of my trig functions. Okay, sine is opposite over hypotenuse. So that's 2/9. All right, that's the one we were given. So that makes sense. Then cosine is adjacent leg over hypotenuse. That is negative radical 77 over 9. Okay, and then tangent is opposite over adjacent. So that's that's 2 over negative radical 77. Okay, running out of space over here. Should I squeeze it in below or squeeze it into the right? I'll squeeze it in below. All right, so the reciprocal of sine is cosecant. So the cosecant is going to be the reciprocal of this, so that'll be 9 over 2. Okay, the reciprocal of cosine is secant, so that's going to be 9 over negative radical 77. And then the reciprocal of tangent is cotangent. All right, so that'll be negative radical 77 over 2. Okay, so those are the answers to problem number 2. All right, let's do one more. This one's going to be in the third quadrant, so let us draw our picture. Okay, so here we are in the third quadrant. Make a triangle. All right, remember that tangent is opposite over adjacent. Okay, so from the perspective of this reference angle, if 4 is opposite, then it's going to go here. If 7 is adjacent, then it's going to go here. So I need to find the hypotenuse. But wait, first of all, we need the signs on here, meaning positives or negatives. So this 4 that's right here, should this be positive or negative? This should be a negative 4, all right? Even though I'm looking at the tangent, it's 4 over 7. That's because a negative divided by a negative is a positive, but this is a negative 4 because it's going down. Similarly, this 7 should be a negative 7 because it's going to the left. So I can use the reference angle and get away with it, but only if I label these correctly with the proper sign. Okay, anyway, let's find the hypotenuse, which will always be positive. So I can just go ahead and do a squared plus b squared equals c squared without worrying about the sign. So 4 squared plus 7 squared is equal to r squared. So that's 16 plus 49 is equal to r squared. So 65 is equal to r squared. And take the square root of both sides. Okay, so let's say the square root of 65 is r, the radius. So let's put that in the picture. Remember, the hypotenuse, the radius here is always positive. Now that we have all 3 sides of the triangle, we can make all 6 trig functions. So, for example, sine of theta is going to be opposite over hypotenuse. So that'll be negative 4 over radical 65. Cosine is adjacent leg over hypotenuse. So negative 7 over radical 65. Tangent is opposite over adjacent. So negative 4 over negative 7 simplifies to positive 4 over positive 7. All right, and then try to see how much space I have for the rest. I'll try to squeeze them in below like I did the others. So the reciprocal of sine is the cosecant. All right, so the cosecant will be just this upside down. So this will be radical 65 over negative 4. The reciprocal of cosine is secant. So just turn the cosine upside down. So radical 65 over negative 7. And that leaves cotangent, which is the reciprocal of this. So that'll be 7 over 4. So those are the answers for number 3. All right, that'll do it for this lesson. I'll see you on the next video.